Welcome to qnawire.
Hey guys, so in this question we have 4 parts all dealing with the combustion and consumption of ethane gas and the energy and enthalpies related to these reactions. So let's go ahead and get started. So in the first part, we need to calculate how much methane will be produced from a specific amount of energy that that natural gas can produce, excuse me. So we know that natural gas can produce this amount of energy, 5,600 EJ. First thing I'm going to do is convert the EJ to joules. It's a very large amount of joules, 10 to the 18th power joules. And then from here, I'm going to go ahead and convert to moles using the delta H that they gave us. So that's 802 kilojoules per 1 mole of methane. Continuing on, I'll convert the kilojoules to joules. So that's 10 to the third kilojoules. Oh, 10 to the third joules, excuse me, in 1 kilojoule. And then I'll convert the moles to grams of methane. And that will yield us, after multiplying through, so all of our units cancel out, and we are left with grams. So this is equal to 112 times 10 to the 17th grams, or we can also say this is 1 times 10 to the 14th kilograms. Next, we have to use the time rate in which they gave us to calculate the time. So here, T is equal to, or start off with our energy that is produced, and then the rate at which this energy is produced, 4.0 times 10 to the second EJ per year. And this is equal to 14 years. Next, we have to calculate the volume that is produced. So we'll start off with our given 1 quart. First, convert the quarts to liters. So that's 0.946 liters. From here, convert the liters to milliliters. And that will equal a mass of 964 grams. Using this mass, we can plug this into our heat transfer equation, which is Q is equal to mc delta T. Let's divide this up so it's easier to see. We can plug it in to find our heat. So we'll use the mass that we just found, which was 946 grams, multiplied by our heat capacity, which is 4.184, since this is in solution, joules per grams degrees Celsius, and multiplied by our change in temperature. So that's 100 degrees Celsius minus 25 degrees Celsius. That yields us a heat of 2.97 times 10 to the 5th joules. Continuing on, we can use this to find our moles of methane. So moles of methane is going to be equal to, we're going to use our energy, our heat, and multiply that by our conversion of 802 times 10 to the 3 joules per 1 mole of methane. This was given to us in the problem. And this yields a 0.370 moles of methane. With this, we can finally calculate the volume using the ideal gas law equation, rearranging it, solving for volume. So V is equal to nRT over pressure. And I'll go ahead and write it underneath here so it's easier. So we'll use the moles that we just calculated, multiply that by our gas law constant, this time using this one, since there is no energy in this equation. Oh, that's a 1. And this has liters per atmosphere, moles Kelvin. And our temperature is 273 Kelvin, since this is at STP. And it is 1 atmosphere. This will give us a volume of 8.29 liters as our answer. Now we can go to part D, our final part, and this is asking us about some fission. So we'll start off with the moles of methane again. So that is equal to 2.0 times 10 to the 13th. Oops. This number was given to us in the problem. So that's the energy produced, and we'll go ahead and use the previous energy conversion for methane. 1 mole methane. And then this is multiplied by another conversion factor of the molar mass. Not a 3. So 4 for 1 mole. Plugging this into the calculator, we find that the moles is equal to 3.99. Excuse me, we're actually finding the mass. Oh. So let's rewrite this. This is the mass. And this is 3.99 times 10 to the 8th grams of ethane. Methane. Oh my goodness, I'm sorry guys, I keep misspeaking. But here is our answer for this. And we can go ahead and use the density equation to find our volume. So V is equal to our mass divided by our density. So we have our mass that we just calculated, and then the density that was given to us back in one of the other parts previously, 0.72 grams per liter. And then this gives us a volume of 5. Try to write this prettier. 5.54 times 10 to the 8th. And this is in liters. And that is our final answer.